Hello. Yeah, as Chris said, I'm Gav. I'm going to be talking about clean code tonight. Clean code is a principle that I drive my life on. If we look at this diagram here, this came out yesterday and it was on the internet. You may have heard of the internet. It's a popular thing I spend most of my time on. Therefore, I communicate primarily in memes. There's someone chopping through code and just, what is all this crap? I don't know if you've ever gone onto someone's code, someone's project, and you felt like that. What's this structure doing here? There's a file, it's not linked to anything, it doesn't even compile. What is it? Where could this bridge possibly lead? It looks important, it says it's important, it says do not delete it, Times New Roman 44-point font. This sign doesn't help me very much. It's a comment saying this is a comment, or something possibly even more redundant than that. And what a horribly designed street, most inefficient, some kind of anti-pattern ball of mud, kind of gibberish. And what on earth does this contraption do? So, always think about programming as if you're going to be working with someone who is a trained killer, which I am, and someone in the room can testify to that, who will hunt you down if they find out that you wrote that code. So you want to be paranoid as a developer, not just as a security professional. Craig, if you could hold the hard object by my mouth. Thank you very much.
Lovely go.
Okay. Okay, so I'm also using Vim. Sorry if you weren't too into the Vim thing, but you're going to have to deal with it, I'm afraid. What I've been briefed with here is, let's make Duck Hunt, essentially. Let's make it in Canvas, and let's make it as badly as we possibly can, and let's make it a little bit better. Duck Hunt was a game on the NES where you get to cap the ducks, and then the annoying dog follows you around and laughs at you. So I'm going to start off with here's one I made earlier. I'm going to be very Janet Ellis. I still fancy her. I grew up in the 80s. So we've got a canvas, that's where we're going to be sticking stuff. We've got pointers to that canvas, we've got a handle on that basically for X and Y, which is our last mouse position. We've got something that moves the mouse around, and something that registers a click, and then we've set up that we're going to draw with a line of 4 pixels, and we've got event listeners added, and every 100 seconds this function renders being called. So this is like the main game loop. So this is how you write games back in the past when we just had a main game loop and that was our thing. So what I'm going to do now is I'm going to define some variables. Duck position x equals 0, and I've used the wrong vimrc, so I'm a bit, it's not indenting correctly, I don't care about that. So what we're doing is we're describing this duck. These are the things that can happen to the duck. Ducks are very important creatures. It's said that their quacks don't echo. I don't think that's actually true. He's been able to convince me of that. So we've set up some things, so the duck's position on the screen, whether it's going down or up the screen, and whether it's been hit. So fairly standard things we're going to need to do, and then we're going to say, move our duck. So every time we render the duck, it's going to move. And what we're going to say is, if it's been hit, if you've hit the duck, let's drop it off the bottom of the screen. Possibly with a comedic quacking effect, which you'll have to provide yourself, because JavaScript and sound, I ain't got time for that. I assure you this will be done in half hour. I'm not like writing a NES game here. So if the duck's going down, as in it's flying downstream, I don't know where I got D from there, it's because them two printer drivers, they're not the greatest thing in the world. Duck going down, it's going to fly down and to the right, so the duck position is going to be incremented by 4. So it's flying down the screen, and if it goes off the bottom of the screen, we're going to reverse its trajectory. I won't tediously type out a whole lot, but I do find it's easier to follow if someone's sort of coding along rather than just showing you a screen and expecting you to grok it, parse it, and lex it immediately. So that's the duck going down, and obviously we'd have the converse for the duck going back up. And then we're incrementing this frame counter, so we'll have a variable for framing, and from the Flash or director background, we're used to the concepts of the frame. Now I'm working in sort of a set of like an imperative programming style here. A little bit of OO going to get thrown in, but this is also relevant in your functional programming styles. Everything we're going to look at here is general techniques for cleaning up your code and making said train killer not hunt you down. So then we do this thing where we draw the duck, which I'm not terribly interested in how that's going to be done at the moment. I'll do my here's one I made earlier routine there, but we'll say draw the duck. The other thing we're going to do is draw the sights. So we're going to have a sight that we're going to do, and the last thing we're going to do is on the click. Well, have we hit this duck or not? So we'll say if it's within. So abs, so the absolute distance is less than 10. By the way, all this code has got deliberate flaws in it, so if anyone's sitting there is thinking Gav sucks, yes, I am a poor programmer, but not as poor as this is making you look. Plus y, less than 10. And I am talking and typing at the same time, it's not doing a wonderful job of either. Okay, so if it's within 10 pixels, the duck's been hit and it's going down. At this point, I will say, I'm opening the here's one I made earlier, which is exactly what we've just been looking at, but as I say, I've put in the code for the duck going back down and the stuff that draws the duck, because this isn't about canvas as such, but just suffice to say we're drawing a V for the duck, and the V goes down or it goes up, depending on whether it's flapping, that's why we've got the frame. And we're drawing a circle for the crosshair, and that's about it. So let's take a look. So we have this duck flapping backwards and forwards, which is wonderfully drawn, and we have this thing, I mean, or whatever noise ducks make, I don't know, but that didn't echo, so it could have been a quack conceivably. Right, that's horrible. If I'd done that in a job interview, I'd expect to be shot, but it does work. So software isn't all about making software work, it's about making it work well and not getting hunted down and murdered in your sleep. I've worked with some guys that probably would do that. That's why I have a bear trap at the end of my bed. So this initial version is a mess. Everything's in the global namespace. It's considered namespace pollution. We don't want that. Why is that a bad thing? You couldn't run two instances of this game on the same page. You couldn't run this on the same page as another game. You might not even be able to run it with a pop-up ad. Something else might have the variable canvas. All this sort of stuff. There's an overlong method, render. A long method is what we call a code smell. It kind of stinks because it's got a lot of variables in. It's doing a lot. It has a lot of responsibilities. In software, we like the single responsibility principle. One thing does one thing. I do overlong bad tech meetings, and it's doing this drawing. It's doing this moving. It's doing this logic. It's doing far too much. Another problem: magic numbers used throughout. Duck position less than 10. 10 what? 10 pints of milk? I have no idea. Code duplication, it's some very similar code between here and here. Often unclear intention, we've got some mix and match. What's X and Y there? No idea what X and Y is. What you want to do with code is you want to be able to read just the line you're reading and have enough context from the surrounding lines to say, okay, I know roughly what this is. But there's no context there, it's in the global namespace and it's just called X. No idea what it is. If it was a class position and it had an X, or if it was a struct that had an X, then we'd know roughly what it was likely to be. And the variable naming is inconsistent. Duck pos X and X. These are all prefixed with duck, these aren't prefixed with anything. And there's no encapsulation. Now, I'm not saying that OO is the only way to write code. Of course, it's not functional programming, all these different kinds of programming, perfectly valid. But we still use encapsulation, we still use data structures, we still use all this stuff no matter what we're writing. So, I've broken my own heart by slagging off my own code there, so I could go home and phone my girl up and have a good cry, or I could get on with it and fix it. First refactoring we're going to use. Martin Fowler wrote this wonderful book, Refactoring. It's not Martin Fowler off EastEnders, which is a popular soap opera watched by people around the country that haven't got tech meetings to go to. So we're going to replace this 10 with, we call it a magic number because it's magic. What does it do? What I'm going to call it is shot radius, sight shot radius, right? So that's my buckshot, that's how big that is. And if I... sorry, my hands are quite cold, so I'm capable of typing and Vim's gone insane. Right, so that's going to say sight shot radius again. Yeah, okay, the autocomplete is not working because my hands are too cold and I'm somewhat nervous. So let's open version 2. Believe me, I'm a consummate professional problem. There we go. So we've replaced this magic number with sight shot radius. So we've got sight size in px as well. That's another one that I've added. We've got duck drop speed in pixels per frame. So we've added all these things that give it some context. So it's a little bit better. You're not just going increment the position by 4. We've actually given units in there as well. It's a good idea often to give units in your variable names. If you do that, then you're not like, okay, was this days, months, years, weeks, buckets of stick found under Rod's bed. We just don't know. You thought I didn't know about that. Okay, so that's the second version. We've made a start. We've made it feel better. We're on the phone to our girlfriend, but we're not quite crying. We just got that sort of thing. So we don't want to go any further than that because, you know, she thinks I'm a big, tough ex-cage fighter, and let's let her remember it isn't me that way. Event mouse move. Look at the indentation there. At least I've used spaces and not used tabs. It's a holy war we're not getting into tonight, but spaces is correct. Easy crowd, easy crowd. So, okay, we've lined up the spacing there, things like that. And also notice I haven't got spaces around my equals here, but I have here. Am I being a huge pedant? Well, yes, but that's what our industry is. That's why we work in this industry. You know, if we were socially skilled, we'd be in marketing, all right? So here we go. I'm putting the spaces around it. It makes it stand out. I can see what I'm looking at there. You always want your arithmetic operands to stand out at least slightly. That's not really the issue. The issue is consistency here. If you have an in-house style, you might not like it. You might have some kind of principal developer who's sitting there going, oh yes, you will use Hungarian notation and M for member variables and this, that and the other. If you want to do that, fine. But you have to be consistent with your house style. But you have to lay your pride at the door, really, because it's really unhealthy. That's what Marcellus Wallace said. That's just pride messing with you. But he was somewhat more coarse about it than that. Pride will damage you as a developer. Pride will damage you badly. And in life as well, but that's another sermon, which I will give if you wish. Did I actually preach as well? So okay, we got rid of some of that inconsistency there. There's still a little inconsistency in my, here's one I made earlier, but Blue Peter wasn't much better than this, was it, anyway, with all the sticky back plastic and all that. So we've made it a bit more consistent with our naming. We've followed some conventions and stuff. Next thing we're going to do is a bit more encapsulation. We referred to earlier encapsulation. I've jumped ahead of myself and opened the wrong section. There we go. So look at all this stuff about a duck. E and G, there we go. So let's put it in an object literal. There's only one of them, so we're going to put it in an object literal for now. We could always refactor it to an object later. And this duck's got all this stuff here. I mean, see, I'm not as slick as Warren with this kind of stuff, but I'm not quite as angry and from London, so so we're getting rid of some of that stuff. I mean, I'll write a quick vim macro here, which I'm going to go. Okay, and if this works first time, everyone in the bar's got to buy me a pint. Well, more or less. Good enough for jazz, as they say. But, so we've started to group some of the things that the duck is all about in there. Next thing we're going to do is take some of this stuff out of render. So let's grab these 20 odd lines there. Sorry, I haven't got the little thing at the bottom of the screen showing you what I'm doing. But I've grabbed 20 lines out there, banged it in here, and I'm going to start saying if this dot hit and all this kind of stuff, rather than duck dot hit this or duck hit this thing that's just in global scope. So I can take these out as well. D. I was going to use NetBeans, but I wasn't going to be upstaged by someone from London. So yeah, these are all getting stuffed in this object literal as well. If you don't know what object literals are, then you know that's fine. It's just like a single instance sort of class sort of thing that you can prototype and clone and all this wonderful stuff that JavaScript is marvellous for. So yeah, we're putting this duck in its own thing. So let's open one I made earlier, much like John Leslie, but with significantly less cocaine and hookers. So there we go. We've got a duck, and it's got context now. So if we look at it going down, it's got context. It's in the context of a duck. It's not just some thing floating in the ether. So we've now got a couple of variables which don't make any sense because they haven't got any context. But we've given context to this x and y that we're using in the duck for the duck's position. The duck now, instead of having an x and a y, has a position. That's a tangible thing. That's a thing that we can understand. So I've used something analogous to a class for that. So when we're moving this duck, we're moving its position. So this is much more fun. So in the render method, so I've only done the one refactoring there, but the next method, the next thing obviously is to refactor that section out, which I'd done both things when I was talking. There we go. So the move method is now moved out of render now. So instead of render doing movement of duck, we're saying duck.move. Now why are we doing that? That's something we call feature envy. The render method seemed rather interested in what the duck was doing. The render method shouldn't be interested in what the duck was doing. The render method should be interested in rendering. The duck should move itself, perhaps, or there might be a duck mover object, we don't know. The design of the system varies. But the principle is, if you are envious of code in another class, perhaps that code should be in your class, or perhaps it's a class looking to get out. I say class could mean function, could mean mix-in, trait, quarter pound of cheese, whatever. Okay, so we leave our drawing code just the same. Next thing we're going to do is we've noticed that this duck, or this duck, when it's drawing, or it's getting initialized, sorry, it knows where it's being drawn, but where is it being? I might skip over this one. I was going to replace that with dependency injection, so it might be easier if I just open that rather than talk through before I do it. Okay, so now what we've done is we've given the duck its own render function, and we've told it what it's rendering to. Sorry, I'm scrolling quite quickly, I found it there. So I've given it a target context. So when I create the duck, rather than just drawing to this global canvas thing we've established, global state is bad, we've injected the dependency. Now there's only one context it's going to be drawing to anyway, but now you could have two instances of this game running side by side and it would still work. Both contexts would be independent because you have injected its dependency. Now inversion of control is the overarching concept here. If that's something you don't know about, it's a good Google, it's a good bit of training to do. Java frameworks like Spring, we use it in Symphony 2 in PHP. There's probably all sorts of stuff in Rails for that sort of stuff, or Sinatra, or whatever your framework of choice is. Reason we do that is we can tell it, you're going to draw to that, you're going to draw to that. So let's go through some of our versions, shall we? I'm going to come out full screen mode. So I'm listing at the bottom the refactorings we've applied, just to catch up. We're about 3/4 of the way through. So we've replaced the magic number as a symbolic constant. We've been consistent with formatting. We've pulled the class out, which is our duck. We've moved the method. We've brought some dependency injection in, and bang, 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 it is still working. The duck still dies like any other duck. So we're feeling pretty pleased with ourselves at the moment. We're getting there. We're starting to communicate better with our code. Things are starting to have a little bit of context, but it's still an awful lot of code happens together. You know, we've got big chunks of code here. Most notably in the duck's movement. Now that's quite a long method, that's a good 20 lines. What reads better, that or something like this? If this is hits, we'll stop drop, else, I usually use curly brackets everywhere, but I'm being quick, this stop flap. So let's follow my own advice. I would say this reads a little bit better, and if like Mark was, you're in the Knuth lecture, that he talks a little bit about literate programming. Now what's literate programming? It's communicating in code and hiding your details away. In the Ruby world they do this in Cucumber. We have your like behavioural driven tests, and you describe it in business language, and then below that you have your actual implementation. That's what I'm doing here. I'm giving it a list of instructions. So I'm saying if it's been hit, drop. That's a verb. Humans understand verbs very, very quickly, so we want to communicate with words whenever we can. And then I would write the drop function, and that's basically the code that I had before. I wouldn't have just ripped it out and deleted it because I've got one up my sleeve. So let's see what we've done there. So we have the drop function, we have the flap function. So it's like reading a newspaper. You read the headline. The headline is this, stop, drop. If you want to read the article, you can drop down into the drop function, and that might have, you know, subheadings. So it's quite a good way to think of your code, is that you're giving it a list of instructions. If someone's code reads like a list of instructions, it's actually very easy to parse and easy to find where you want to be, and the call stack gives you semantic information. The call stack gives you meaning. So when you have meaning in your call stack, it's brilliant. You're like, okay, well this is doing this, this, this. It makes sense. Method naming is a very difficult problem, variable naming, very difficult problem, but I tend to spend maybe at least a third of my time as a programmer naming stuff. There's some deliberate bad naming in this, and even at the end of the refactoring there remains bad naming, and it left as an exercise to the reader, as every smug bastard book writer ever has said. Basically means I haven't finished the job. But yes, literate programming, Knuth, these are things that as a software professional I'm interested in. I can't understand 2/3 of the stuff the guy says because it's very mathematical, and I'm a simple man who's taken many blows to the head over the years. Next thing I'm going to do, and we're almost home now, so thank you for bearing with and still being with me, is going home is hit. We've got two booleans there. We've got matrix 1, 2, 3, 4. So we've got 4 possible states there, but really there's only three states that I want it to have. If you end up with a lot of booleans in a class or something, you've got to ask yourself, is it really a switchboard like that, or is it a set of states? It's really easy to throw booleans in, but what I'm going to say is I'm going to give it a little bit more context. Again, more semantic information, more telling people what I'm doing. Flapping down. No, flapping. This is like an enum or whatever I'm using this as, and what's the third state? Hit. It's been hit too. So I'm using states rather than loads of Boolean flags, and what I find generally is that communicates a little bit more meaning to the person reading my code, making them even less likely to end up in the bear trap at the foot of my bed. Okay, so let's go on to version 10. So that's the one that I've applied this to. All this code's available on my GitHub. It's also on the Amaxus blog, I think, somewhere, under refactoring to clean code, which is my talk title, which I should have said at the start. Possibly didn't because I was excited about a pitch. So the next thing we're going to do is we're going to decompose a conditional. So if we look at after that, this thing here is great, but it's doing what we want it to do. But is it so good, really? I mean, it's a lot of information in there, and it's all a little bit too much for a little bit of code. So if we have a look at version 12.htm, see what we've done there. Looks like the syntax highlighting. There we go. Okay, so instead of having all that stuff that's just, is this near this, is that near that, is that in this radius, I am a Dalek sort of thing, we've said sites.test for hits. Now the sites knows how to test for hits for a point, a duck's position, and if it is, you send a message to the duck. Now, object-oriented programming is the paradigm that's my background, primarily, and it's all about sending messages to things. If you send a message to something, then that provides a lot of meaning. It provides, it's easy to mentally model. So yes, we're sending a message to the duck saying it's been hit if the site's test for hit comes back and tells us that it has been hit. So that knows how to do that. So we're dividing up the responsibilities a lot better. Now let's have a look how big this thing is. Shift-G takes me to the end of the file. 186 lines. Our original version was smaller by about 40, 50 lines. So we've got more code. More code's often a code smell, but in this case, we've made everything more explicit. We've made it clearer. We've made it able to run in multiple instances, or we will do in a second. And we've communicated intention a lot better. Now what we could do now is obviously have the sites in one file, the duck in another file, and the game code in another. So it's decomposing this thing. As the system gets larger and larger, the responsibility to decompose it becomes stronger and stronger. So I'm going to go to the final version, and what have I done here? Last thing I've done is put it in a package, effectively. What's bracket match? What's skip to bracket match, Warren?
Percent.
Percent.
Of course it is.
Right, settle down. I've only been here 5 minutes, you're already being a dick. Yeah, so that's it. End of the lecture, basically. And what I want to say with this is, well, that that puts the game in its own thing, and it means that you can have multiple instances and all that good stuff. You're not polluting the global namespace with anything then. Right. What's the summary of this? Well, the summary is back to where we started, really. Trying not to leave other people in that situation that we've all found ourselves in, where we've just felt lost, we felt frustrated, we've been unable to work on a project. Bearing in mind that communicating with humans is actually harder than communicating with computers. You can just punch the information to a computer once. People require explanation, they have feelings, they infer meaning into things. It's very difficult to communicate well to humans. What I don't want to see redundant comments. I don't want to see people feeling they have to write reams of documentation beyond the stuff to get it set up, get it running, and explain the system overview. Code can be reasonably self-documenting and can leave people not frustrated. Not saying that my example I've got to a perfect point, but these are some steps along the road that you can take. If you're interested in this kind of approach, the books I'd recommend are Refactoring by Martin Fowler and Clean Code by Bob Martin, calls himself Uncle Bob, and on Twitter. And there's also Pragmatic Programmer, which many of you will have read. And what's the other one? Kent Beck did an excellent book I can't remember the title of at the moment. But reading these books and thinking more about the human implications of software is something that's enabled me to remain in employment despite the fact that I'm largely incompetent. So, because I can communicate with people, the machines are getting by, but when the Terminators rise, I'm for it. So thanks for listening, guys. I hope you enjoy the rest of the evening. Feel free to come chat to any of us. God bless.